Welcome back to part 2 here, Huskies. It's Mr. Naughton. We're going to do our proofs. For our inscribed angles, I want us to go back and look at our rules here really quickly. So remember, the inscribed angle means that if this is the angle and this is the arc, that if we're getting larger, I'm going to multiply by 2. So it'd be 2 times whatever that angle is. So what's also important is our inscribed angles that have a common arc. So see how they share this arc right here? So that means this would be 60, this would be 60, this would be 120. You good with that? And then last but not least, we have our quadrilateral and our right triangles one. So if we have a diameter, that means that this has to be 90 degrees because this is 180. That's what diameters do. And that these opposite ones are supplementary. Okay, so now we have our tool set for our proofs. So in this one, what we're going to try to do is we're going to try to prove that AD, this arc right here, okay, is going to be the same as BC, this arc over here. Now, if we know that, notice those two go to these two arcs right here, okay? So if there was only way to say that this arc right here and this arc right here were the same, sorry, those two angles were the same, excuse me, then I could say that the arcs were the same. And we can do that, so let's go ahead and show you how. That's using our parallel lines right there. So if this is parallel, and this is parallel, and we think of our diameter as our transversal, then this angle right here and this angle right here are going to be alternate interior angles. So let's write down our given. So first, that AB is the diameter of circle P, and that's given, step 1. And then I'm going to use that AC is parallel to BD, and that was also given. Alrighty, now I'm going to use my alternate interiors. So I'm going to erase this so I can see my letters a little bit clearer. So angle CAB, so CAB was this one, is going to be congruent to PB, I should say angle ABD, and because those are alternate interior angles. So if we need to draw that again, parallel line, here's my transversal. This angle right here and this angle right here are the same, okay? So if those are the same, then we could say that arc AD, that's not an arc, let's fix that, is congruent to angle, or to arc, excuse me, CB, and we just talked about that theorem way up here, so let's remind ourselves, it's that common arc inscribed theorem. So common arc inscribed theorem. Remember, you can also just write these out too. You don't have to use the actual names. All right, so our next one, we are starting with just given that I have circle P, that's it. And we're going to use some similar ideas. But in this case, we're proving similar. So our similars, for similar, remember we only have a couple of options. It was side, side, side proportionality. And since I see no numbers, I'm going to have to skip that. Then there was SAS proportionality. Once again, no numbers for side, so I'm going to have to skip that. So my only options there are angle, angle similarity, which means that I need to prove two angles are the same. So here we have an inscribed angle. Here we have an inscribed angle. And once we can see that those go to the same arc. So I'm going to go say that angle H is congruent to angle L. And it's that same theorem, that common arc inscribed angle theorem. And then we're going to do the same thing over on the other side because we just proved that this angle and that angle were the same, okay? Actually, let's take it up a notch. Let's do vertical angles. See, you could do vertical angles right there. But since we are in our circle unit, let's look at these arcs right here. So they share on this one as well. So I could say that angle J is congruent to angle K. And that's the same thing, that common. Now again, if you did this beforehand and you did vertical angles, we're going to be just fine as well. So we have a lot of options for this one. Okay, and so now that we proved our triangles similar for angle similarity, triangle KLM is similar to triangle JMH by angle similarity. Remember to put that little similarity fact right there, sports fans. But that's it for today. Nice short video. We'll see you next time.